I hope everybody's got the message that we're recording this. Angshuman will introduce himself, and I thought best to have a Rebreather instructor give us more about Rebreathers. And so while we're waiting on a few others to join, any questions can be put in the chat box, and then Angshuman can take them later on. And hello everyone, yet again for another series of the webinar series.
Okay.
So Angshuman, you can go ahead with your introduction and then start the presentation.
All right. So yes, most of you here know me, but for the benefit of those who don't, I am Angshuman, and I have been diving for the last 12 years, and but that has been completely open water scuba. Over the last couple of years, I've kind of developed an interest on rebreathers, especially the last 2 years. Have been doing a little bit of rebreather diving, and thought I could share this with my little experience with you guys, since we have quite some time on our hands from doing what we regularly do, that is be in the water. So yeah, I would like to definitely thank Vish and his team at Scuba Evolution to allow me to use their platform to kind of share my thoughts and whatever knowledge I have on rebreathers. And maybe some of you are looking at moving to rebreathers or trying out rebreathers. So whatever questions I can answer and share my experience with you guys, and help you, make a decision on rebreathers. The way I would want to keep this is very, very basic, to give you an idea of what rebreathers are and very basic functionality of the rebreathers, different kinds of rebreathers that are available in the market, and then I would share my the way I look at it. What are some of the advantages and some of the disadvantages with rebreathers, and then we'll take any questions, and hopefully we'll be able to answer some of the questions that you might have. Like I said, I will try and keep it very simplistic, so that the understanding is clearer to people who haven't had any experience of diving. I'm not sure if there are people here who haven't dived at all, but if there are, for their benefit, we'll keep it really, really simple. So yeah, we'll talk a little bit about the origin. Most of you guys, it's basically connected not really with the origin of rebreather diving, but also diving as such. Just some timelines, that's about it. The basic principle of rebreathers, how is it different from open water? Different types of rebreathers. Now, when I say types here, I have categorized them in very broad types. There are so many different types of rebreathers, but try to keep it simple, just give you the basic differences, and then advantages, disadvantages, and then who can do rebreather diving. Are the slides up?
Yeah, you need to put it on full screen so you can start the presentation from your laptop and then go ahead.
Okay.
Because we can only
presentation. Okay, here we are. That's why I was wondering.
Just click on your present screen and that should work.
Yeah. Sorry guys, I'm a little bit technologically challenged when it comes to computers. And
says the Rebreather instructor.
Yeah, doesn't require you to do any presentation. It was working fine, right, earlier? I don't know what happened now.
Yeah, you need to click on the on your PowerPoint presentation and just go full screen.
Okay. And everything here is in German, so a little bit takes me some time to. Oh, come on.
Where's the redundant computer?
Yeah, I have the other one as well, but I'll have to log into that.
You know what? You could just not and just go with the slides. It's full screen and on the screen right now. So we just scroll slide by slide instead of doing it full screen as well.
Why is it not happening?
Well, you know what they say, Murphy will come whenever he doesn't know. Most uninvited guy.
Does this work?
We can see a screen. We just need to see the slides move. I mean,
because I can see my slide.
Does anybody else have the same issue as I do? My screen is just frozen with Anshuman's with the.
Same here.
Oh.
Okay. Hang on. Then let me run the presentation, Anshuman.
Yeah, you can run the presentation and then that's fine as well.
So you can just keep talking for a little bit. Venkat, as usual, our guru has given us, the great thing that I could run the presentation myself. Thanks, Venkat.
Angshuman, press F5 now on your screen.
F5.
F5 brings up the presentation, like where I can see your scuba evolution presentation. Just press F5. It goes on presentation. Then you can enter and it will go forward and you can speak in.
F5 enter.
Click on slide and press F5.
Yeah. That's what I'm doing.
Anshuman, I'm getting worried about your presentation here.
Yes, I can understand.
And as usual, right now my keynote is kicking me out. Oh, wonderful.
Full screen. Did it make any changes?
It's completely gone black, so I think it's coming up.
I can see the presentation screen. Just click on that and press F5. It will go on the presentation mode.
That's what I'm doing, Chief. नहीं हो रहा है.
Okay, just stop presenting and I'll present. I think my thing should be open now.
Anshuman, use your dive computer.
Battery.
Multiple organ failure.
Typical rebreather problem.
Yes.
All right. So as Vish tries to bring up the presentation, I have pretty much given up right now. As he brings it up, I'll just give you a brief about the history of rebreather diving, also connected a little bit with normal open circuit diving. So the first ever rebreather dive was done sometimes in 1680. So it was just a bag of air with with a metallic loop, which was used, and obviously it didn't end up well. But that was the first time someone ever tried with a completely closed circuit rebreather. Obviously, there was no injection of oxygen. It was just a normal air bag. The only thing was there was no exhalation out into the environment. So this was the first time someone ever tried. In the 1700s and 1800s is where a lot more development happened in terms of people learning more and more about nitrogen, oxygen as such. Oxygen started being used as a independent gas for breathing underwater. Also, in the early 1900s, once the famous Mr. Haldane figured out the decompression techniques, that slowly started getting incorporated into diving. When I say diving, it is purely scuba diving, not necessarily rebreather diving. In the 1930s is where we learned more and more about nitrogen narcosis. The phenomenon of nitrogen narcosis was, really came into light, and people started knowing more about the effects of nitrogen, partial pressure, and all of that. But whatever development happened with rebreathers during these times was mainly restricted to the military use. And in the Second World War, one of the success stories of rebreather use was there was a battle which was fought. I just need to, I think, cancel my presentation, or so I stop presenting. And so Vish, you're presenting, right?
Yeah, I'm in. I will just start in a second, and yeah, we're good to go. So we have the presentation going on.
All right.
And yeah.
So yeah, as I was saying, there was a big, huge success story with the rebreathers. This was in the 1940s, in the Battle of Gibraltar, where the British gained a big advantage over the Italians. Both of them were using rebreathers, but the British gained advantage because they were using nitrox rebreathers as compared to rebreathers that the Italians were using, which was pure oxygen rebreathers. For obvious reasons, they had the advantage they could dive deeper than 6 meters. As most of you would know, with rebreather diving, it has always been very, very heavily dependent on technology. And even though there has been, huge leaps in terms of how technology has developed in the 1970s and 80s in terms of rebreather, it was still mainly used in military diving and a little bit on the surface with firefighters and all of that. In the early 90s is when the first rebreathers were introduced by some of the companies for sport diving, or recreational diving as we call it. And even then, if you were to ask, I have spoken to some old-time divers, and they have said even in the 1990s or even in the early 2000s, if somewhere were to ask them, would you move to Rebreather, they would not trust it as much as they do today. And I'm not saying that today all the problems have been ironed out, but since it's so heavily technologically dependent, with the advancement of technology, the rebreathers are getting better and better as time passes. So 1990s is when the first sports diving rebreathers were introduced by some of these companies. Most of these are pretty famous: Draeger, Kiss, Inspiration, Halcyon, Maris. All of these are still in the market, and they have come up with, from what they introduced in the 1990s to what they have today, been huge technological advances. So if we can move on to the next slide. Rebreather, as the name suggests, is the way it's different from open circuit scuba is when we breathe in an open circuit scuba, when we exhale, the gas is released into the environment. In Rebreather, we rebreathe the air. That is why the term comes, is called rebreather. I will try and walk you through the circuit that the gas follows. Again, from a very, very bird's eye view. Obviously, there is a lot more which is happening inside. I will try and explain a little bit of that at a later stage in the presentation when I talk about the individual parts. But as of now, I'll try and explain the general functioning of the rebreather as it's on this picture. So we will start with the exhale hose. So the way the rebreather works is the whole thing is in a loop. So there is no air which is released into the environment. So let's talk about, we'll start with the exhale hose because it's clearer, it's a little bit more easier to understand if we start with the exhalation rather than the inhalation. This is what we also use when we conduct our first open water sessions or the first training sessions. So as you breathe out, what happens is the exhaled air passes onto something called a scrubber. A scrubber is a canister. It is a unit which basically with your exhaled air, which has carbon dioxide in it. So when we inhale about 0.04% carbon dioxide. But when we exhale, the exhaled air has about 4% carbon dioxide. And carbon dioxide obviously is not something which we would want to inhale. So as the air passes through the canister, what it does is it scrubs the carbon dioxide, and what comes out of this scrubber is just the oxygen content. Now, exhaled air, as most of us know, has still about 12 to 16% oxygen. Now, that oxygen in a normal scuba unit is wasted and it is, exhaled out into the environment. Now, here in the rebreather, we use the same air, enhance it with whatever requirement is there in terms of what oxygen is needed, and we breathe it again. So as I was saying, the carbon dioxide is removed and the scrubber, and then the air passes into something called a counterlung. A counterlung is nothing but something which is a counter to your normal lung. So as your lungs deflate, the counterlung inflates, and as you inhale, the counterlungs deflate. So it is countering the action to what is happening in your lungs. Now, as the air goes into the counterlung, there are sensors both outside the scrubber as well as before it enters the counterlung. There are sensors which senses the percentage of oxygen and what percentage of oxygen you need at a particular depth. That is dependent on the partial pressure of oxygen. calculating that, it delivers oxygen and then it goes into the counterlungs again and you inhale. So this is a very, very basic explanation of how the loop works. Like I said, I will explain a little bit more details as we go into the parts a little later. Now, the whole idea of the slide before. The whole idea of rebreathers is based on partial pressure of oxygen. Now, most of us would know that we cannot exceed the partial pressure of oxygen to go beyond 1.4 or fall below 0.4. Yeah. So the sensors make sure or try to make sure that it remains within these levels and delivers the oxygen, trying to keep optimum of 1.3 to 1.4 as you would have set the rebreather to act. One of the big advantages, we'll talk about it later, but one of the big advantages, as you can clearly realize, is you are carrying much less really less quantity of gas as compared to what you would carry on a normal scuba dive. Even if I go to a 20-meter depth, I can go with 2-3 liter cylinders filled up to 200 bars, and that dive would last me on paper it would last me anywhere between 10 to 15 hours, yeah, which is almost impossible when it comes to open water scuba diving. Another advantage of rebreather diving is the air which you are breathing is moist and it's warm. So which is not the case when we dive with open water scuba. And how it helps you is it keeps you warm, and it also reduces your work of breathing, which means it causes less stress in the body, and that works out to be a huge positive when it comes to the overall work rate of a diver. Here the consumption of the gas is not based on depth. On a rebreather, the consumption of gas is based on the work rate of a diver. So, obviously, if a diver is stressed or he has other things to do while diving on a rebreather, his consumption will be higher than, because his carbon dioxide production would be higher. Therefore, the whole circuit, as I had explained, would be working at a higher rate than it would be if you're completely gone on a fun dive and diving without any additional workload. So these are some of the obvious advantages of rebreathers. If you move on to the next slide, I'll talk about some basic types of rebreathers. Like I said, there could be so many different kinds of rebreathers if you get into the details, but we'll just keep it to very simple, just to explain the main differences between rebreathers. The first one, which was also one of the initial ones which was developed, is called the oxygen rebreather. The only gas which is unloaded is 100% oxygen, or medical oxygen, 99%. And this has a lot of limitations in terms of how deep you can go with this. You cannot dive with this to more than 6 meters because of the partial pressure of oxygen, which will harm you if you go any deeper. So this is mainly used for military use, and also for firefighting, because you are on the surface and a single gas, which is oxygen, does not cause any harm when you breathe it for a particular period of time, not for extended time. And this is where the main use of oxygen rebreathers are. Obviously, there are oxygen rebreathers, which is not for diving, but rebreathers which are used for medical purposes or in space, all of that. But like I said, we will not get into that. We'll keep it mainly to diving with rebreathers in water. The next one is a semi-closed circuit rebreather. This can use more than, apart from oxygen, it can use mixed gases. It can also use just the air diluent. This is very, very prevalent in the rebreather industry. A lot of people dive on semi-closed circuit rebreathers. One of the reasons why a lot of people dive on this is, even though it is still dependent on a lot of electronics, a huge percentage of the functions are diver controlled. So the diver has more control over this, and therefore he is able to trust it more than a completely electronic closed circuit rebreather. So here a lot of cave divers, so Vish would definitely would have seen most, and a lot of cave divers dive with semi-closed rebreathers, because cave divers, as I know, like to keep most of the operations to themselves and their slates, and depend less on their computers. I remember in the last presentation which Vish did on cave diving, he had mentioned that most of the times he just apart from a computer, he just carries a bottom timer, and one of the reasons is because he has planned the dive so well, or he would have planned the dive so well, that he trusts his planning more than the computer. So that is why it is something which is very, very popular among cave divers, because most of the functions are still diver operated rather than computer or the machine operated. The next one is a closed circuit rebreather. In the semi closed circuit rebreather, what also happens is there is a continuous flow, so you can adjust the flow, but it's still a constant flow of the diluent or the oxygen. So what happens in this is, that's why it's called a semi-closed circuit, because you have to regularly vent out air in this. Yeah, the gas is regularly vented out. Again, it can be done by the diver manually, or it can be done by the unit on its own. But there will be continuous and regular venting out of the gas from this particular unit, and that's why it's called a semi-closed circuit, because it's not fully recyclable. All the gas is not fully recycled. That happens in a closed circuit rebreather. The difference between a semi-closed circuit and closed circuit is primarily that in a closed circuit rebreather, you are not venting out any air, at least when you are diving. Most of the air is vented out only during your ascents. This is something which is really, really popular amongst technical divers who go beyond 80 or 90 meters. This is something which is really, really popular. And because of the air not getting vented out, its use or efficiency is 20-25 times more than what you would do on an open circuit. Just to give you a very, very basic example here, if I dive to 30 meters on a open circuit with, let's say, one tank or 12-liter tank filled up to 200 bars, the dive is probably, if planned well and dived well, last me probably 40-45 minutes. That's what we usually do. Now on a closed circuit, if I, let's say, carry the standard 3-liter bottle of air diluent with a 3-liter bottle of oxygen filled up to 200 bars each, which means I have 600 liters of oxygen or air diluent, and both. This taking an average of, on the higher side, a human consumes about 1.5 liters of oxygen a minute. So let's make it 2 liters of oxygen a minute. with 600 liters there, it is still going to give me 300 minutes of dive time with just carrying 2 3-liter bottles instead of carrying 1 12-liter tank. So this is it increases my dive time by huge amounts. I can keep reusing it. Obviously there are other things to consider when I'm reusing it, but the general advantage is absolutely amazing when it comes to rebreathers. So a lot of people have this notion that rebreathers are mainly for technical divers. Yes, they are the ones who take the most advantage of this, but rebreathers are also very, very popular now, getting popular amongst researchers, photographers who keep their dives to 15 18 meters, and they can dive for long, not worry about carrying too much redundant air, and have a beautiful and amazing dive. Now all these different kinds of rebreathers are broadly again categorized into two types, which is a mechanical closed circuit rebreather and an electronic closed circuit rebreather. I've just put that down. If you just press the button. So in the mechanical closed circuit rebreather, what happens is it is the diver who has most controls over the entire unit. So whether it is injecting the oxygen, or it is venting out the air, or it is even during a bailout, all of it is controlled completely by the diver. That's why it's called a mechanical closed circuit. And the other one is an electronic closed circuit, which is everything in the unit is controlled electronically. So there are sensors which monitors each and everything that is required for the dive, whether it is injecting of air, injecting of oxygen, reducing the pressure in the loop. All of that is done by electronic sensors, and they do the adjustment. So the difference between advantages of a mechanical versus an electronic rebreather, if you ask most of the people that I have seen, and these have been guys who have dived the last 15 18 years, most of them say mechanical is what they still would go for. But a lot of them are now moving on to electronic rebreathers. And with electronic rebreathers, you always have the option of keeping pretty much, I would say, 85 to 90% of the operations manual. So even though they continuously, they dive regularly with electronic rebreathers, they still try to keep it manual in case they feel that something has gone wrong. They have the control on themselves. So it's basically a hybrid kind of a rebreather which people use nowadays, which has got everything E, which is electronic, but in case of an emergency, they immediately, instead of letting the electronic operations do the bailout, they take over and do it manually. So this is something which a lot of divers who I have spoken to, including some of the big instructors, all of them say that they still don't completely trust the electronics. Fish, I'm not sure if he's there. For him to move on to the next slide. Yeah. So now we'll talk a little bit about the different parts. Like I said earlier, the first one is the scrubber. A scrubber is basically a canister which holds something called sulfonylime. This is nothing but hydrogen, sorry, not sodium hydroxide and calcium hydroxide. And when carbon dioxide or the air passes through this, there's a chemical reaction which happens for the people who are, big chemistry professionals, I can send you the formula, but I won't be able to, break it down here. What really happens is a chemical reaction there, and it gets converted to nothing but calcium carbonate. So all the carbon dioxide gets converted to calcium carbonate, which is, most of it is nothing but lime. And another byproduct of this entire chemical reaction is heat and moisture. So the heat and moisture gets recycled into your breathing, and all the carbon dioxide is absorbed at the scrubber level. Then it moves on to something called the counterlung. As it goes through the counterlung, there are sensors which sense what percentage of oxygen has come out from the scrubber, and depending on your depth, it has already calculated what percentage of oxygen you need to breathe at that particular depth. There is an injection of oxygen from the oxygen tank which you are carrying, and then it goes back into the counterlung from where you can inhale. Now the counterlung also is basically, there are two bags. One is the inhalation bag and one is the exhalation bag. So the exhalation bag is always inside the inhalation bag. So as the exhalation, if I can just show it here, as the exhalation, as you exhale, what happens is that inside the counterlung there is another counter reaction, which there is another counter mechanism which is happening. As you exhale in the exhalation lung, the inhalation bag gets activated. So there is basically, this reaction happens. Yeah, if you can see my hand, I don't know if you guys can see my hand. So I can see a lot of things happening on my screen, so I'm not sure if you guys can hear me. It says your mic is off. Can you guys hear me, or am I audible, visible?
Yes, you are. You are audible.
Okay, cool. So yeah, so as so this is what happens in the scrubber. It basically is scrubbing all the carbon dioxide and giving out oxygen back to the counterlung. Another term which is used is the HUD, or the heads-up display. This is nothing but a display which is right in front of your eyes, attached a little bit in front of your mouthpiece. It is a very, very old school display, but a lot of people, almost all the divers use it. It's got a green light and a red light. Now, both these are sensing two things. One is the partial pressure of oxygen in your breathing loop, yeah, and the other is if there is any water, yeah. So these have been already set. The set point is already fed into the system. So the moment it exceeds or it is below the set point, the red light goes on, which means there is something wrong. Or as long as everything is good, it's the green light which is always on. So this is a heads-up display. Even though you have highly sophisticated computers which people use while they are diving, the heads-up display is something which most divers would like to always have, because this is something which is, whether you are looking at your computers or not, this is something which is visually right in front in your line of vision. So most divers use it, probably not as a primary computer, but something as an indicating computer which indicates if something is wrong, and then they would, if the red light goes on, then they would check their other computers and then see what the problem is. Sorry guys, I'm getting a message. I'm not sure if it's Vish, so I'll just have to check this. All right. The next one is bailout. We'll probably come to bailout once we go through the other ones. Again, I don't see the presentation here. So we will talk a little bit about the onboard computers and sensors. Now there are, okay, there it is. So there are, like I said, bailout is something which we'll talk about probably once I go through the other parts, and then we'll come to bailout because I want to spend a little bit more time on bailout. We'll talk about the onboard computers and sensors, which is the next point. Most of the sensors which are used, so there is no part of a rebreather which doesn't have a sensor. And all these sensors are completely independent in terms of their circuitry. So they are not attached to the other sensors in terms of their power supply or their waterproofing or any of that. So they are completely independent, which means the data that they are feeding, or that the data that they are generating, is an individual data of that particular sensor. Now every part of the rebreather has multiple sensors as well, and all of this can be calibrated to your computer. So which means when you are reading your computer, you are reading data which is from sensor 1, sensor 2, sensor 3, and if there's a problem in any one of them, usually they will show us different the readings will also be, this is from sensor 1, sensor 2, and sensor 3. So if the way we usually do it is, if 2 of the sensors are calibrated, and if there's a usually 3 should be calibrated, but if at least 2 of them are showing the same readings, then everything is fine. If 2 out of the 3 are showing separate readings, then we go on to something called a bailout. Otherwise, as long as 2 of 3 are giving the similar or the same data, then we are fine. So yes, the computers and sensors are absolutely independent. There are multiple sensors in each part of the entire unit. So that builds in a lot of redundancy, which is what is required, especially when you are depending a lot on the electronics. I have dived on a few rebreather units. All of them have been CCRs, and I have mainly gone with the eCCR option. I dive on the JJCCR, and even though it has an option of going manual, I have so far, apart from my training wherein you have to use the manual options, I have not yet had the ever needed to go on to manual, because the sensors have been working absolutely fine, and they have always been calibrated. So like I said, over the years, the technology has developed. Most of the sensors have gone through extensive testing, and even though I do carry a lot of bailout gas when I go diving, follow procedures which are required to be followed, but I trust the sensors quite a lot, and it is something which is getting better every day. I have spoken to people who have been doing this for years and years, and their experiences, it's getting better and better. Still doesn't mean that we should not be going manual, or at least having manual options, but yes, the sensors are getting better every day. One of the things which I thought I will just tell you, since I'm still a beginner in rebreathers, when I did my rebreather, I did 10 hours of diving on the rebreather. I felt I know everything about rebreathers. I did about 40 hours on the rebreather, the same unit. That's when I realized I'm pretty much a novice. Now I've done more than 100 hours on the rebreather, and my realization is I'm just about a beginner. So the more you, because there is so much to know and so much that can happen with the rebreathers, specifically because it is so much technology which is involved in the entire unit. The more you dive with it, the more you learn. So yeah, that's a little bit about the sensors and the computers. The next thing we'll talk about is counterlungs. I just wanted to share this with you. Counterlungs, there are 3 different kinds of counterlungs which are there with different kinds of units. Each manufacturer has his own reasons why he puts counterlungs, where he places the counterlungs. I will. So the chest counterlung, something which has come up, I think Mares has come up with this Triton. I haven't dived that unit, but they have, it's a semi-closed circuit rebreather. They have a chest mounted counterlung. So the entire counterlung is at your chest. The advantage of that is, since it is so close to your lungs, it pretty much functions very similar to your lungs. So the whole idea about counterlungs, and having spoken to a lot of divers, what they say is it is basically the ease of breathing which changes with where you place the counterlung. Some people find it easy to inhale, some people find it easy to exhale, and each have their own feedback, and whatever is suitable for, or whatever people like, is what they go for. Certain units come with a fixed kind of a mount which you can't change. If it's a back mount, it stays as a back mount, and certain units you can always, after diving for some time, whatever you prefer, you can move the counterlung to a chest or a back, usually to a shoulder or a back. Chest is something which is very, very new, and like I said, Triton from Mares, or I think, yeah, one of these is a chest mounted counterlung, and I've heard really, really good reviews from people who have dived on this unit. The JJ comes with a back counterlung, and with the back counterlung, sometimes the exhalation might be a little bit more, you might need to work a little bit to exhale, but it really, really doesn't matter too much. So I prefer a back mounted counterlung. With the shoulder mounted counterlung, which a lot of people prefer, I have tried it for a few hours, and from my little experience, I can say, though it is really comfortable to exhale as well as inhale, it kind of restricts your head movement a little bit because of the way the shoulder mount is connected to the entire unit. And that's the only option you have to connect the, it's kind of a T, there's a T mount which connects it, so it restricts your head movement a little bit, and that's why I would prefer the back mount. Even though the back, when you go back mount, you can, there's a huge distance between your lungs and your back, so that is where the difference comes when it comes to exhaling and inhaling. Okay, so like I said, this is something which is a personal preference. Certain manufacturers will recommend which mount you should go for, but it is something which, once you dive with a unit, you will get comfortable, and whatever is what you like is you should go for that. Bailout options. So yeah, what is a bailout? Obviously, in case of an emergency, you bail out. Now, why would you bail out? So many different reasons. As in normal scuba, things can go wrong. Things can fail. Your sensors can fail. Your electronics can fail. There can be a mechanical failure. So many different things which could go wrong, and that's when you would bail out. Also, a bailout doesn't necessarily mean you bail out to the surface. Sometimes it could be a temporary bailout where you see that there's a problem. Maybe one of your computers is showing a high partial pressure or a high pressure in the loop. Yeah, and what you do is you bail out, fix the problem. When you bail out, basically what you do is from your closed circuit, you move to an open circuit. There are different ways of doing it. One is you can just push a button on your mouthpiece and it goes to an open circuit, or you can completely remove the mouthpiece and go on to a independent gas supply, which could be a tank with a dedicated second stage. Fix the problem and then get back to your closed circuit. So that could be one of the bailouts. There could be a bailout which is a bailout all the way to the surface. Bailouts can also be stage bailouts. There are different kinds of bailouts. So bailout is basically an emergency which you might have to attend to. It could be a temporary bailout or a bailout to the surface. Just would want to touch upon something here with the mouthpiece. There are two different kinds of mouthpieces which are there in the market. One is a BOV, which is a bailout valve, wherein there is just so your mouthpiece is here. There is just a push of a button. You just, as a lever or the entire thing, you just move it, and it goes to an open circuit. So from a closed circuit, it goes to an open circuit, wherein it gives you access to your diluent gas which you are carrying. Or you can also, if you're carrying a tank, you can also, there's a quick connector which you can connect to your loop, and it gets converted to a open circuit. This is one of the bailouts. The other one is also called a diver surface valve, wherein you, in this case, you remove the entire mouthpiece and go on to an independent one. So in this case also you have to push a lever, and what the lever does is it closes the entire system so that no water enters the loop, and then you can go on to a completely independent second stage which could be connected to a tank. So these are the two different kinds of mouthpieces which are there in the market. One is the BOV and one is the DSV. Most people prefer the BOV because when it is a highly, let's say you're on a dive and something has gone wrong, so what happens is because of the stress, your carbon dioxide levels could be quite high, and the entire exercise of taking this out, moving on to an independent one, you might not have the ability to do that. Instead, it is easier to just switch a button and move to open circuit. So most divers prefer to have the BOV, but then again there are divers who find more advantages on having the DSV as the option which is there on your mouthpiece. This is something again which you can customize to what you prefer, depending on your experience, how you feel, and what you feel about it. What else? Probably a little bit about I just wait for Vish to move on to the next slide. Yeah. So disadvantages. Obviously, one of the biggest disadvantages is the cost. What we say in when you go to rebreather diving, what we usually say is, if you have a lot of money to spare, then you should go for rebreather. Or if you want to get into it completely for educational purposes or for teaching or something, then you should get into. It's not really something which you can just go as a pastime, okay, unless you have the money to spare. It costs a lot. A good unit would cost you anywhere between $6,000 to $12,000, and The next one is your training. Again, very, very extensive training required. You need to have very in-depth knowledge of the entire physics, a lot of more laws that we need to learn apart from the usual Daltons and Boyles and all of these. We need to learn a lot more laws and how it affects diving. Gas planning is one of the biggest things you will learn if you were to get into rebreather. And one more thing which adds to the cost is the equipment requires very, very high maintenance and servicing as well. So you also need to understand how to maintain your equipment, how to service your equipment, and usually the service technicians as of now are not available as commonly as they are for your open circuit scuba units. So these are some of the disadvantages of rebreather diving. The advantages, one of the biggest advantages, obviously, the fact that you carry so much less gas. It is so much more efficient than the open circuit. Like I had said earlier, it is about 25-30 times more efficient than your open circuit scuba. Something which the rebreathers are recommended. They are highly recommended for technical divers. One of the reasons is they don't have to carry so much gas with them if they are diving on rebreathers. So we carry lesser gas, and then we have stage decompression, which remains the same. And because you're diving on a rebreather where your partial pressure of oxygen is maintained at a constant level, your decompression timing becomes much less. Your exposure to nitrogen becomes much less. So these are some of the big advantages for technical divers using rebreathers. Also, like I had mentioned earlier, even for normal recreational fun divers, photographers, because you're breathing warm and moist air, it is absolutely amazing how much of a difference it makes to your general physiology and the rate of breathing. You are so much more relaxed. You don't feel cold. Even I have dived in cold waters here in Germany. Obviously, I was wearing semi-dry, but still, it feels so much more comfortable when you're breathing warm and moist gas, which makes a huge difference to your rate of breathing. So that's another advantage. Like I had said earlier, carry less gas. A 3-liter oxygen bottles at 200 bars can last up to 300 to 600 minutes on a recreational shallow dive, 18-20 meters. It's something which is absolutely amazing when you do with rebreathers. One thing which I don't think I've mentioned here, but in open circuit, what happens is we all know that as we inhale, we go up. As we exhale, we come down because of the entire changes in the volume. Also, what is happening is there's a constant change in the overall volume that you are carrying because you are letting out air into the environment. That doesn't happen in rebreathers. Your overall volume pretty much remains the same because everything is in a loop. You're not venting out air. So first time when you dive with a rebreather, buoyancy is a big, I won't say big, but it's quite a challenge. Okay, the questions I'll take later. So yeah, that is something which is something which we need to get used to. But once we do a little bit of diving with a rebreather in a pool, it's not something which is too difficult to get used to. There's a new concept actually which a lot of people are talking about, even though we say that, for someone to get into rebreather, you have to be at least open water diver, enriched air diver, should have 50 log dives. But there's another school of thought which says, why, if someone who has never, dived ever in their lives, why can't they straight on start with rebreather diving? Because they don't have the concept of buoyancy, carrying a scuba tank with an open circuit. So why can't I get them used to a rebreather diving from the very first time they get underwater, which is also a school of thought, though none of the agencies have yet made it, have started accepting divers without any experience, not that I know of. But that's another school of thought where they say that someone with absolutely no experience, why can't he or she start diving on rebreathers from the first day itself? But yeah, so these are some of the things which I thought I would share with you. I wanted to share a little bit about, I'll probably have a look at the questions, share a little bit about gas planning with you guys, just to give you an idea of how you plan your gas. All the gas planning that is required in rebreathers is not based on how much gas you are, you have on your loop, or how much gas you have attached to your unit. It is the off-board gas which you plan for when you plan gas planning in rebreathers. Because in case something were to go completely wrong and nothing works on the rebreather, the way we say is you still need to have enough gas, which is completely independent, to get you back to the surface, which might include decompression as well. So that's how you plan your gas. Just to give you a very, very basic example, let's say we go to we go to a wreck which is sitting at 30 meters with overhead environment, get inside a wreck. So at being conservative, let's say at the rate of, and we are diving on air, let's say on air. So apart from my rebreather, which I would have already planned for, the other thing which I need to plan for is my bailout gas. So the planning would be somewhat in these lines. So if I were to dive a wreck which is sitting at 30 meters, let's take a conservative high air consumption of, let's say, 14 liters a minute. Yeah, at 14 liters a minute at 30 meters, every minute I would need. Now this is for people who have been diving. For someone who's not, probably I could, if you have questions about how I came to this figure, the others will just get it. They would have already, started getting the answer. So let's say at 14 liters a minute at 30 meters, I would need, at every minute I would need about 56. Yeah, 56 because the pressure is going to be 4 bars, 56 liters a minute. Now let's say I'm already inside the wreck, and keeping the general principle of wreck diving in mind, I am, say, about at the point of time 5 minutes away from the ascent line. Yeah, so to swim back those 5 minutes, 56 liters a minute, I need 280 liters. Yeah, that's 280 liters just to get me back to the line. And remember, now I'm talking about, we are absolutely normal. It's a normal dive. Now, why would you want to come back to the line and do all of this? Obviously, because something has gone wrong when you're inside the wreck, which means your overall work rate would have gone up. So the way we calculate it in rebreather diving is, we calculate it as your overall work rate has gone up about 3 times. So about 280 liters is what I need to get back to the ascent line. 280 liters into 3 times is about 840 liters, just to get me back 5-minute swim from inside the wreck back to the ascent line. Now I'm sitting at 30 meters. Now I have to do the ascent at, let's say, 9 meters a minute and a little bit of decompression. So all of this would require at least another 1,000 liters of gas, which means I would need about 1,800 liters of redundant gas to be carried with me when I'm going to dive to a wreck of which is sitting at 30 meters. Yeah. So this is how we generally calculate gas planning, which means I will probably have to carry a 10 or a 12-liter tank filled to 200 or at least 150, 180 bars. So this is just to give you an idea of how we plan gas on a very, very normal recreational dive. Now just imagine a diver, let's take Vish, who's diving a cave, and he has a swim of, let's say, 75, 80 minutes, each way swim into the cave. Yeah, so that now you can calculate how much more gas planning he has to do to come up with a number which would be enough for him to come back to the entrance of the cave or to the surface. Yeah, so this is how we usually calculate the bailout gas. There are some new theories which have come up wherein a lot of divers do not carry so much bailout gas because they trust their system, and they say that 1/3 of the gas which I'm going to use is going to come from the rebreather unit itself, and the other 2/3 I can carry with myself. Also, during the decompression stop, they prefer to breathe the oxygen from the rebreather itself. So various theories. It is something which is evolving every day, and this is how we we calculate our gas supplies or gas management. This is how we do it. So I will probably move on to some questions and see if I can answer some of the questions which you guys might have. Okay. First, there is something in Spanish from an Indio, I'm sure. Yeah. And then there's a question. How much spit deposits in the counterlung for a day, 1 hour dive? I think Anindio has this question. So there is a membrane which sits on the counterlung before the air enters the counterlung. So in terms of spit depositing, there is no spit which deposits inside the counterlung. I hope that answers your question, Anindio. Do you pack your Sofnoline? Yes, you do pack your Sofnoline. So there are two kinds of canisters. One is the axial canister, wherein the flow of the gas as it goes through the scrubber is from top to bottom. That is the axial. Click to cancel your presentation. That's the axial scrubber. The other one is the radial scrubber, where what happens is the gas moves from the sides to the inside or from the inside to the sides. Now, when you are packing the Sofnoline, it is easier to pack the Sofnoline on an axial scrubber because you just kind of pack it up, whereas it is much more difficult to pack the Sofnoline on a radial scrubber because of the way the radial scrubber is constructed. So it is much more difficult to pack the Sofnoline on the radial scrubber and easier to do it on the exhale. So I use the radial and I do pack it myself. You can, it is just a little bit, you have to pay a little bit more attention. That's about it. So tech diving is better on open circuit. Rebreather has a extra weight as backup. Yes, why not? An option. Rebreather can be your bailout option, and tech remains open circuit. I haven't really done any tech on the rebreather. I have done, most of it has been a maximum of 40 meters. So yes, I have done tech on open circuit, and I would, as of now, prefer to keep it that way. But it's a good, I think it's a really good suggestion that if you keep rebreather as a bailout option, I think it's absolutely great. Lesser decompression and all of that, so can be used. Thank you, Anindya, for that suggestion. Do you get certified for a particular equipment, or is there a Yeah, so you do get certified usually for a particular equipment. So like I am certified for JJCCR, and there are so many of those, and you do get certified from for a particular unit, and obviously the certifying agencies, most of the certifying agencies do pretty much all the units which are available. Some of the really common ones right now in the market are Triton, XCCR, SF2. SF2 I've heard is really good. I've tried SF2. I didn't enjoy it so much. JJ is becoming quite popular again. So yeah, you do get certified for a particular unit. And is there any? No, there is no universal certification, because every unit has its own mechanism which you need to learn. Even though they are similar, but they are not the same. How many years before there is sufficient confidence in the rebreather system to carry out bailout gas? Good question, Kush. He asked how many years.
Anshuman, just one sec.
Yeah.
Can you move your screen a little bit closer, because you can only see the top of your head.
Oh, which is not very pretty.
Yeah.
Not that the bottom half is, but still. So how many years before there is sufficient confidence in the rebreather system to not carry a bailout gas, or will that never happen? So Kush, there is a saying, which is something which my instructor told me, that 20 years back, if I told you, you sit inside your car, open a bottle of Coke or a bottle of beer and tell your car to take you from place A to place B, will it be able to do that? You would have probably said no. Today, Tesla has pretty much made that possible. With rebreathers, the difference, I hope it is possible, but the only difference is the environment, because the environment is so diverse, and what it can do is something which is very unpredictable, unlike when you're on a road. Yes, probably in India it is still quite unpredictable, but yeah, I guess you understand what I'm saying. So a lot of the feedback which has come from the experts, they say that yes, this would be an ideal situation, but it's going to take a long time. I personally believe that there will always be a little bit of problems with the system, because there are electronics, and I don't know how far the electronics technology is going to develop and how it can develop. I'm not someone to comment on that, but I would really hope that it develops in a way that we can trust it 100%. But as of today, no, it is not developed to a stage where we can stop carrying bailout gases. Will that ever happen? Hopefully it will.
So what I know is that the most of the cutting edge cave exploration is happening with redundant rebreathers.
Yeah.
So you carry a rebreather as bailout. not use it until it is required.
Yeah.
So that's what people are using now. I mean, it's trustworthy enough for a bailout, and therefore you don't carry so much open circuit gas, but you still stage a lot of gas, because when you're doing 200 250 meter dives, that gas is not enough. Even your onboard gas is not enough. So you need to carry enough off-board gas and stage it. But yeah, they're using dual rebreathers, dual canister, multiple canister rebreathers.
Cool. Lost the question. Yeah. Next one is particular equipment, no general certification. So I think Venkat kind of answered the question which someone had asked earlier. So yeah, it is always the equipment which you get certified for. There's no general certification. What does the MFGR certify? I'm not sure what the MFGR stands for.
Manufacturers. It's just manufacturers.
Okay.
I guess.
And still, I'm not sure what the question is. What does the manufacturer certify? So
I guess the question is, I mean, exactly what you already answered, that it is a unit, to be more specific, it's a unit specific certification, which the agency takes from the manufacturer, and once you train on a particular unit, it is basically certified by the agency, which is then, and there are a lot of redundancies written into the manuals and to the documents, which very clearly say that if you don't use it as per the manufacturer, then the training agency is not responsible. If you don't use it as per the training agency, then the manufacturer is not responsible. So it's a huge loophole game that they keep playing in the rebreather world. Still, they haven't made it as black and white as it is in the open circuit game.
Yes.
But it's always a unit specification.
Yes, it is very, very manufacturer specified. Just to give you an example, so we have these, various standards which the units have to meet. So the JJR, the CCR doesn't meet one of the standards in Europe, which is if you were to dive completely vertical, which is head down first, completely vertical, there might be overload into the loop, which is not something which is accepted in the European standards. I'm not sure about other units, but JJ has mentioned this in their manufacturing guidelines, but it then gives you an option of a manual, you can manually let out the pressure from the loop. So it is very, very manufacturer certified standard. So that thereby you have to always get certified on a particular unit, because it could be very, very small changes, but it is different. Yes, Nuno Gomez doesn't trust rebreathers. I know that. Hopefully someday. But yeah, Venkat has, how's Hollis, Chief? To be very honest, haven't dived on it, so I wouldn't know. But yeah, I from what I know is most of the rebreathers which have come into the market after 2007-8 are really quite dependent rebreathers. Also with rebreathers, one of the things is you can kind of construct your own unit as long as you have the knowledge and the parts. You can always mix and match as long as you know what you're doing. So I'm sure Hollis, as the name goes, it's I'm sure it should be a really dependable unit. I can vouch for JJ. I can vouch for SF2, and I would definitely try the Triton because it is a very easy to use unit, is what they say. And I will share my whatever I'll find with the Triton.
So the Hollis Prism is actually a very good unit. it's a technical unit and can be used for all sorts of dives. It's been used for a lot of exploration as well. The Explorer, which is the SCR, is
Yeah.
not too popular amongst divers for some reason. Whether it's the cost or it's the maintenance or it's just the lack of flexibility, but the Prism is the one which is more recommended for rebreather diving with the Hollis. That's what I know. But given that the Mares Horizon is another new SCR which has come in and also has a technical, can be switched to the same rebreather can be switched to technical as well.
Yeah.
So maybe that would be a better option than the Hollis Explorer. But if you're going for purely a full rebreather, then the Prism is what you should look at if you're looking at Hollis.
Okay, thank you for that, Vish. What gas do you use for BCD and dry suit? Is it the same from the loop or is it from a different source? So what goes into the loop or what goes into your BCD? The source is the same. So it is your air diluent which goes into it. Obviously, the way it's connected is different. It doesn't go in from the loop. It goes in from your diluent cylinder, which is then split and you can inflate your BCD / your dry suit. I hope that answers your question, Ramesh. Lawsuit, okay. Okay. As usual, Anindyo is having a lot of fun. And Vish loves mechanical CCR. Probably yes, I'm not sure. Vish would probably comment on this if he loves the mechanical CCR or the ECCR.
Yeah, I'm going to get the Sidewinder or the Sidekick. So that's going to be my first CCR that I get. CCR. I might actually. I'm thinking of the Mares Horizon SCR as a training tool to start off with. But CCR would be the MCCR, the Sidewinder or the Sidekick. I mean, they are just built for exploration and they're built to not break.
Yeah,
So
I've heard really good things about the what's the one from Mares, the SCR?
Horizon.
Yeah, I've heard really good things about the Horizon.
That's the same Explorer which they took and they modified it a bit with the Revo. So with Revo coming, Mares buying Revo, it's just taken over everything from they've put it out. There's a lot more that's gone into the manufacturing. I think Sid is here, so maybe he can tell us more about. Is he here? Oh no, he's not here.
I am here, but not really the right person to talk about something I'm not qualified to. That being said, we were going to announce this shortly, and if you guys don't mind, we'll be doing a SCR webinar with Mark Crane, one of these in 2 weeks or so. He's the international instructor trainer for the SCR Horizon, and I was going to talk to Vish separately about it actually. And yeah, I mean, he would be actually the right person to ask any and all questions you have about the Revo as well as the Horizon.
Cool. There's another webinar Mark Crane is doing tomorrow, I think, with Scuba Tech India. I'm not sure whether that is going to be on the SCR, but it's on the rebreathers.
That is more, he's doing it as a TDI thing. I did have a word with him regarding tech diving in general. It's not focused on a rebreather or a SCR system in any way. What we intend to do is a focused seminar on the SCR. I mean, nothing else, nothing more. No, nothing less, nothing more.
Oh, that's great.
I think
Kush
Kush asked a question, which is, how does one select which model manufacturer to go with? Kush, from my personal experience, I tried out about 6 different kinds of rebreathers with totally different configurations. It is your personal experience. Obviously, there are other things to consider, like the cost, what kind of diving you're going to do, Are you going to do, tech? Are you going to do cave? Are you going to do, recreational? That also has an effect on your decision. But the best thing to do is to spend at least a couple of hours on some of the ones which you would shortlist, and then make up your mind. That's what I did, and I was really, really impressed with the JJ. And I tried the SF2, JJ, the Inspiration, Mega. I tried a few, but this is the one which really, 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 I loved the JJ, and that's why I went for it. So it's completely personal, and I would recommend that you dive on different units also to get a feel of how each one functions. I'm not sure when we can travel again, but whenever I come to India next, I will carry my JJ and bring it to the pool in Goa, and then all of you can have a try. Because it's going to give me a lot of hours, so no problem with the scrubber.
So, one more thing which need to think about, Khush, is that like what Anshuman was talking about, the maintenance of a rebreather is extremely extensive, and if you do not have right maintenance facility available in country or in your location where you're diving, then you're going to have problems. It's going to be not problems, it's going to be more expensive trying to sort it out, which is why a basic rebreather course also means that you understand how to build it and put it back together, and that's the basic stuff.
Yeah.
You could also do a rebreather tech course, which adds on money, but if you're spending about $10,000 to $12,000 on a system plus another $2,000 to $3,000 on the training, another $500 on getting how to know how to maintain it, shouldn't be much of a issue.
Yeah, with the rebreather training, one thing, guys, is you would go and spend money on a rebreather training only because you plan to buy one. Otherwise, there's no point getting certified on a rebreather because you don't know where you are going. If you're going to go dive there, they have rebreathers available. So, definitely it's you select the unit, try it. Once you like it, get certified on it, and you should have your own unit because no one is going to give you a rebreather unit to dive on, at least not yet. Maybe it will come into the mainstream and people will start renting it out, but as of now, I don't see it happening in the very, very near future. So it is something which you guys should keep in mind, that if you're getting certified on a particular unit, that's the unit you're going to buy. You should know inside out of that unit. Okay. Is it possible to mix tech diving certification along with rebreather certification? Yes, you can. In fact, it's highly recommended that you are a tech diver before you get into rebreather, just because of the amount of material that you got to read and the amount of calculations that you got to make. So, and the because tech diving is quite task loaded when you get your certification, whether it's tech 45 or 65, doesn't matter. It is quite task loaded, and rebreather certification also is quite task loaded. So it prepares you in a way, both in terms of theory as well in terms of practicals, to handle the entire situation better. So I would definitely recommend that you have some kind of tech certification before you go into rebreather certification. It's not a requirement, but I would recommend. I hope that answers your question, Ramesh. What about flight rules with tanks? No, you can't have filled tanks on flights. You can carry empty tanks on flights. That's not a problem, but you can't carry filled tanks. So you'll have to basically get your tanks filled at your destination. So without the tanks being filled, rebreather unit, again, depends on the unit, but could weigh anywhere between 7 to 12 kilos, and ready to dive anywhere between 12 to 16, 17 kilos. And this I'm talking about just the diluent and the oxygen tank, usually a 3-liter tank. Obviously, if you add in more bailout tanks, but those are completely different. So that's the flight rules with tanks. Empty tanks only allowed. Wish, in your tech webinar, you said you have your BCD fail on your dives. Is there a chance of the lung bag failing here? Well, guys, when you say lung bag, that's the counterlung you're talking about. The way it's manufactured, it is, you know, completely protected. Should not, but you know, it's something which, like in any other part of even a open water scuba unit, everything is so well, you know, protected. But can it fail? Yes, it can. But the chances are, chances of it failing a lung bag is very, 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 very less. The way it's manufactured, I don't think I can explain in this forum how the entire thing is manufactured. Like Anindya says, it's 1 in a whatever 150 million chances for that to happen. Yeah. I hope that answers your question, Akshay. What we usually say both in tech and rebreather diving is anything that that can go wrong will go wrong. So you know, you prepare for any and every emergency. That's how it works. But again, the counter lung failing is something which is almost, I haven't heard of it. Any idea about Rebreather Training Council? What is their role and its relevance? To be very honest, no, I haven't really, spent time.
So I can take that on.
Yeah.
The Rebreather Training Council is just a group of concerned agency and agency heads and Rebreather instructors and Rebreather instructor trainers who have gotten together and formed a board where they, along with Dan and a few other safety agencies, where they take a look at the protocols, the checklists, and all the training materials relevant to rebreathers. And they've come up with what should I say, a protocol and a set of guidelines, so to say, that make it safer and make it more training intensive for rebreather diving to be more appropriate. This was again after a few deaths happened, which were based upon, which is what happens most of the time whenever there is a large scale event of deaths, when people start waking up and start looking at things. So it's more of a safety oriented group, and they have been forming up. They've formed up for quite a while now. I think RF3 Rebreather Forum 3 was in 2016, if I'm not wrong. And anybody wants to put the proceedings, you can get them online. But mostly they are a group of concerned safety agencies, DAN, training agencies, international training directors from various agencies, and international Rebreather instructor trainers who have gotten together and formed, like the RSTC, for example, it's just a Rebreather Training Council. So that's what it is.
Thanks for that, Vish. How much weight do you usually carry with a rebreather? Same as open circuit? No, it is not same as the open circuit rupee. Usually it has the kind of unit you're diving on, what you are wearing in terms of, just your shorts and t-shirt, or are you wearing a dry suit? But usually it is anywhere between half the weight you would carry, or even like Anindya said, 1/3. I usually carry with my JJ on a semi-dry. I carry 1.5. So yeah, it's definitely different from the open circuit. Why do you have the counterlung in the first place? You have the counterlung because that is what enables this question from Akshay. Why do you have the counterlung in the first place? The counterlung is there to enable your breathing. So as you need something which uh, you know uh, gathers the exhaled air and pushes out what you need for inhalation. So the whole mechanism is based, like I had explained earlier, the whole mechanism is based on, like the name suggests, counterlung. One gets empty, the other gets full. Your lungs get full, this gets empty. So that is how that is why the counterlung is there. Because otherwise, without the counterlung, the breathing, the whole mechanism of breathing will not be possible. You will have to come up with some other device which is going to act, but you will need something to enable the breathing for the entire unit. I hope that answers your question, Akshay. Because we want to remove the carbon dioxide on the canister, yes. How do you descend then? Because if you exhale the air, yes, questions are getting answered, which is making my job easier. Yeah, you do the same. You deflate and you descend. So similar. Is it difficult to suck air from the system without it? Never tried. I don't think you will be able to. The way the mechanism works, I don't think you will be able to. You will really have to probably suck air, if at all, for it to function.
So there'll be no loop, so therefore it's not a system. It's not closed. In a rebreather, if you remove the counterlungs, it's not going to be a rebreather anymore. It's just going to be open hoses, unconnected. So it's just and the bill goes in. The delivery goes into a different. There's no loop, so it's not a loop anymore.
Yeah, the mechanism will not work because as your lungs will get full, there is nothing which is going to push out the air. So that's the way it's manufactured. So first get some open circuit tech experience, then try some different rebreathers, then choose an instructor. Yeah, that is the ideal way to proceed. That's how I did it. So I think that's a decent and recommended way to proceed. Obviously, like I said, you can go the other way, wherein you are an open water diver with nitrox and 25, 30, 50 dives. You can do it that way as well. But this is, if you are really serious about rebreathers and want to take it to the next level, I would say this would really help. The volume of air remains in the system at. Yes, so Rupi, the buoyancy is something which is something which you get used to as you dive more and more with rebreathers. Initially, it's going to be we all have had quite a few dives. I had quite a few dives as well before I dive with a rebreather, and I spent, my first session was about 3 hours. I spent 2 hours 59 minutes on the floor because I just couldn't so that it takes some time to get your buoyancy right, but yes, since the volume remains the same, it's not decreasing, you get used to it. How do you control it? It's not with your breathing anymore. It is just the air which you have in your loop, and it's a question of getting used to it. It's difficult to explain how exactly it works in terms of how you control it, but you will figure it out maybe in 5 minutes, or maybe like me in a couple of hours. So totally depends.
Okay, and so I'm just going to stop the recording right now, and we can take questions thereafter because it's just going to get too long to upload then thereafter. So thank you for all your questions so far, and we'll continue the question answer session once I stop recording. And thanks, Anshuman, for the insight onto rebreathers, and thank you all for being here.
Thanks a lot.